Hello and welcome to today's video where we're doing even more leetcode. So in yesterday's video we completed the backtracking topic and now we're moving on to linked lists, I think it is. Yeah. So I'm just going to start watching the video now and I'll update you when I'm finished. Okay, so the first problem here was middle of a linked list, and basically the way we do it is we have a slow pointer and a fast pointer. So we start the slow and fast pointer originally in the same place, and we have a while loop, while fast and fast.next. We're going to basically increment the slow pointer by one. I know it's not incrementing, but I go to the next node from the current node, and then with the fast pointer you go 2 nodes ahead. That will mean when the fast node gets to the end and no longer satisfies the condition of the while loop, that will mean that the slow pointer is in the middle, or at the second second middle, because that's what the problem asks. So let me just get it up now. Oh yeah, by the way, Google's released Gemini 2, which is apparently pretty good. Still not as good as DeepSeek or OpenAI or Claude for programming, but yeah, I have to test it out one time. So middle of linked list leetcode. I may have solved this before. I don't know. I know I've seen the solution to it before, but yeah, solved. Okay. So I'm still gonna write it out anyway. So, well, I could refactor this by just doing slow equals fast equals head, and this will still work. But I think for when I'm writing it down, I will have the more verbose but clearer version. So we're gonna have slow equals head, fast equals head, while fast, and fast.next. So it'll be slow equals slow.next, fast equals fast.next, dot next, and when we exit this while loop, we'll just return slow. That was it. Yeah, okay, and I'm just going to do a visualization. So 1, 2, 3, 4, 5. So here that'll be the middle one, and 1, 2, 3, 4, 5, 6. Okay, so we have 3 and 4 as the middle values, and then we pick 4. So this, I'm just gonna do it in pen. So the slow value here, we have the fast value on top, then we have the fast value here. Okay. So here fast dot next doesn't hold true. Okay, very simple first problem. Add that to my leetcode problem file. So let's go to the next one. I'm just gonna remember to mute this time. Okay, so the next problem is called linked list cycle. So here we just want to find if our linked list has a cycle in it. So for example, you could have 1, 2, 3, 4, and then it loops back to 2, then it would just be a repeating cycle like that. So yeah, I'm just gonna get my pencil out and try and just come up with a solution myself, because apparently it's possible to do it in of n time, constant time, because it was a follow-up question on the leetcode problem. So let's just try and get a solution first, and then we'll go from there. Okay. Right. So back to the problem. Actually, no, I'm going to get it up on leetcode. So linked list cycle leetcode. And what number is it? It is number. Oh, it's taking so. Okay, 141. It's an easy problem, according to leetcode. So, well, I mean, surely we can just do R equals while So while v underscore head if v underscore head not no if v underscore head in R, then we return true. Else, if it's not, we have to append this to the array. So r dot append v head, and then we can do v head equals v head dot next. This might be quite slow, but surely it's just Irvin memory complexity. Okay, I don't know why I did it like this. It's a bit lopsided, but anyway. So I probably won't even need to do this. Okay, let's just leave that out because I think the input parameters are mutable. So R equals like that. So while head if head in R, return true. Else R dot append head equals head dot next. Return false. Need to add this in here. Oh, runtime 17 milliseconds. Not looking great. I mean, we have the Irvin lookup here, and this function itself is Irvin. Wait, okay, it's been accepted. Beats 5. Is this Irvin? Because surely if we're trying to find a value, I reckon this is Irvin squared. Surely there must be an easier solution. Okay, this is. How many milliseconds is mine? 2,000! 2 whole seconds. Ooh! Okay, I'm just thinking about how I would do this without storing each value in an array. Okay, I'm just going to go through the solution on here, and yeah, I'm going to try and just see the better solution. And my pencils run out of lead. It still seems I got lead in there. Okay, I digress. Okay, I'm going to mute my audio. Okay, so I've just gone through the solution, well, watching the solution, and it's another slow and fast pointer technique. So basically, yes, it's pretty much the same as the problem before. So we have the slow pointer incrementing it by 1, and then fast pointer incrementing it by 2, and eventually, if it's got a cyclic structure, the slow pointer and the fast pointer will eventually be equal. And if we get to the end of the linked list where they haven't been equal, then we exit the while loop and then we just return false. So I'm also going to write this up. So I'm just going to copy this down. Okay. 3, 2, 0, 4. Then if we put 4 back to 3. Okay, so let's see. So we have slow equals head, fast equals head, while fast, and fast.next. Okay, yeah, let me just increment slow, the slow.next, fast equals fast.next, .next. Then we can do if slow is equal to fast, then we return true, and outside this while loop we can just return false, because that will mean that the fast pointer has reached the end of the linked list. Right, that's that one done. Pretty simple. And I'm going to go on to the next one. Oh yeah, and just by the way, I'm 2 hours 46 minutes and 16 seconds in, if you're following along in any way. Okay, so the next problem is we got to reverse a linked list. So yeah, I'm going to try and go through this also before looking at the solution. This is one of the common problems, like if you can't reverse a linked list, I don't know, it's a bit of a stereotype, but I don't know. Okay. Google.com. What am I typing? Okay. Reverse linked list leetcode. Uh, 206 did I read? Yeah. Okay, so just thinking about this. Oh, okay. What if we merge? This might not be the solution, but I'm just thinking through it. What if we find the middle pointer, and then... Okay, do I have a sticky? No. So, what if we find the middle pointer, and then we set... Oh, no, do you have previous? No, we don't, that's the problem. Okay, so what I was thinking, if we had the previous one, we could just find the middle one, and then we can go out, and then flip them, then go out and flip them. So, I mean, I guess it would be possible, surely. Let me think. Okay, so say we found the middle one. What if we... This might seem a bit stupid, but what if we store each of the nodes in an array? Then we find the middle one, or the middle two, and we can just flip them. Or could we just simply just append it all to array, flip it, and then set the... Okay, this may seem just stupid, but I'm going to try it out. So for while head, r.append head equals head.next. Okay, so then if we just do... How do you reverse in... No, it's just for iron range then R. So then can we do then R minus 1 R at I dot next. Sorry, we need to sort this, so R, it's like that, isn't it? R dot next equals R at I plus 1. Then how do you, can you just set null? Null in There's obviously going to be a much more efficient way of doing this, but this is just our first solution. Okay, none. I mean, that's quite simple. And then R at len R minus 1 dot next equals none. Return R at 0. Is it just we return the head? Oh, just index out of range. How? How is that possible? How can we... The length of array minus 1. How is that ever possible that we go out of range? Okay, I'm just gonna assign. No. Length of array. Can you do... Does that work? So it's not out of bounds. What? This object has no attribute. How to get last value of array in Python. I thought it was minus 1. Oh, is it? No, there's no need for the colon, is there? Index out of range. How? Yeah. Okay, maybe if we just comment out this and see what it takes us to. I think we'll have just infinitely spiraling one. I don't know. Yeah, time limit exceeded. So, okay, fine. I'm just gonna temp equals head -1, and I'm gonna set because dot next equals temp dot next because that'll be null. Oh. Let's see. Memory limit exceeded. How? How are we exceeding memory with such little? Oh, head equals. What is going on? Look, what I'm trying to do is I'm trying to append each individual node into an array. Then I'm flipping the array, reversing it, and then I'm going through each of the values in the array and setting each respective value to the value at the index above. No, sorry, next to on the right of that value, and then I'm going to. I don't know. Okay, let me have a quick look at the solution. Actually, before that, let me just think. So, what if we did? I mean, if we're adding everything to an array, there's pretty much no point using that flip method. So, could we just use bubble sort? Like, we compare the two. Okay, so if I'm just still going to submit this. I know it's not going to be right, but at least it saves the code. Let's speed up. Okay, memory limit exceeded. Right. So now, what if we do a bubble sort type thing? O of n squared. For no. So head equals. So now who's cur is head. Next equals. Oh well. Okay, so okay. What if we do prev equals head, and then cur equals head. No, should we say cur next, and then while cur val equals cur.next. So what I'm thinking of doing is having another array where, so we would have the one, then we have it here, and then you would get the next value, and then do this value dot next equals prev. Okay, so cur dot next equals prev, then cur equals val. And then what if we just return? It would be cur, surely. And that would be prev. Wait, no, it wouldn't. Okay, let me just see what I get when I return prev. Don't tell me memory limit exceeded. Surely this is just then. No, sorry, of 1. Time limit exceeded. Oh, great. Val equals cur.next. Cur equals val. How is this going to be an infinite loop? Okay, this is just for debugging purposes. Or should I just bring this into Godbolt machine node? So then I would need to make a linked list. So let me just have a count. Print count. I think it stood out somewhere on leetcode, so it's easier to debug. But yeah, we have debug premium in leetcode. Yeah, so how are we? Oh, memory limit exceeded now. How? Is this just? Oh, okay. So we got some scandal going on. Val equals. But how? Let me think about this. So, okay, let me just get a whiteboard. Online whiteboard. Like, the intent of what I'm trying to do may not be clear. Okay. Let me just go back to the web whiteboard, the one I was using before. Locked. Create a new board. Miro literally has a monopoly of like online whiteboards. Okay, you can load. May just be quicker at this point to explain it by. Right, let me just think. This is awfully convoluted, so let me try doing this without count, because I don't want there to be. So val equals cur.next. Oh, how do we just create a copy? Like, I don't want this to be referencing the same object, if you know what I mean. Yeah, this could be the source of our issues. Shallow copy versus deep copy. I know how to make a deep copy versus a shallow copy of an array, but just not a singular value. let's go here. Okay, copy. Okay, deep copy. So let me just try to deep copy. I'm not sure if this is in LeetCode, but okay, I'm just gonna do deep copy on both of these. But if I like just put them in parentheses, does this? Yeah, well, it's not like C++, I suppose. Non-type is not. What? Non-type is not actually next. What's it done about? Okay, at this point. Well, I know the intent of it. Why don't I just do it in C++? Okay, I'm also going to submit this. I know it won't work, but the usual making use of. Oh, okay, we're actually getting output here. Right. Okay, let me just do this in C++. Oh, what have I done here? Was this my solution? Let me just make sure this is saved as well. Oh, good equals true. Right. So, we're going to have our list node cur equals head. And then, no, so this is going to be code up next. List node previous equals head. Then while cur. Oh, what am I writing in Python? While cur is not equal to null cutter, then we're going to do cur dot next. But this is still going to have issues with. I've got my semicolons again. Okay, and then we're going to have our pref equals cur this node now. Oh my god, but yeah, okay, we're having some issues with pointers at the minute. Now equals cur.next. Okay, and then cur equals now. Okay, I am almost 100% certain this won't work. Because we do. What? Ah, and I'm even just resulting to Python. I'm forgetting my semicolons. we return cur. Well, technically we don't want to return cur, but undefined behavior. Remember access with equals. Okay, let's just enclose this. No, head. Next. If head. Next. Else return head. Right. I got number access within. Okay, right. I'm just going to go to the solution at this point due to the obfuscated issues. Okay, so the solution he went through was the solution I was trying to achieve, but was not managing to. So let me just so first I'm going to write it up here. So we're having our previous prev equals none. Then we have cur equals head. And then while cur is not equal to none, then we're gonna initialize the next pointer, and you'll see why we need this in a minute. It's to it's when we change our pointers, we need cur, because cur.next will equal to the pointer before. We need some way of getting to that other one because our link between it will be gone. Okay, so next equals cur.next, and then is it the reason? Yeah, code.next equals prev, and this is especially useful. I don't know why we're starting head and then cur equals head, because we need some way. Yeah, it's just don't know what it's doing. So cur dot next equals prev, and then prev equals cur, and then we've got to assign cur to next pointer. Okay, cur.next. Then at the end of this, we need to assign head equals prev, I think. Yeah. Because prev, when cur is equal to none, prev will be the last one. So, yeah. Right, so let's code this up. Yeah, so it's basically the intent I had, but it was just cur equals head. So while head is not equal to none, then we're going to do so first of all we're going to do next equals cur.next, then cur.next is prev, and then prev equals cur, and then cur equals next, then we do head equals prev. Yeah. Oops. Okay, we're going to need to rename. I'll do next val. Non-type reject has no. How can this ever be next? This is a problem I didn't get. Okay, the prev equals none, cur equals head, and then next equals cur.next, cur.next equals prev, prev equals cur equals next val. I just don't get it. Like, this was one of the errors I was getting before. Has no attribute next, but how can cur ever be none type if head we're checking? This could never be executed if head is none type, surely. I do not know. Let me go to the solutions. First of all, let me just submit this because okay, I'm gonna go to the solutions. And I'll take a look. Solution video. Okay, let's just see the solution. Template is head.next equals node. Yes, we're just doing this like it's basically just a swap. But yeah. Okay, so we get the intent of the code. And I'm just going to write it out here. So 1, 2, 3, 4, 5, and then do 5, 4, 3, 2, 1. Okay, so that's that solution done. And okay, so this will be the last problem from the like video course we're going through. But I just want to take a quick look at today's problem on leetcode. I tried it in break today, but in some cases I was getting double the amount of numbers. So this links back to the permutations problem I did yesterday. And yeah, let's see it. So basically, what we want to do is I sub 0 times I sub 1. We want to check if that's equal to I sub 2 times I sub 3. For I being, I think that was tuple with the same product. Okay. Submissions. Yeah, you can see I'm getting double here. So, okay, let me just copy this and put it in here. Yeah, so this is my solution. And I'm going to go back to the description. So, my problem was, I think, was that number of tuples such that A times B equals C times D. So here, okay. So here we want to do 5. Okay, let me just go back. Runtime error also. Okay, sorry, it should be 4. Yeah, so this isn't working. And I think the reason this isn't working is because, well, let me just check. So, I'm just trying to see the, okay, so the tuples here. Would we need to call backtrack on each of these individual ones? Okay, it's, yeah, the mistake I was making was thinking that every one was of constant size of 4, but that's obviously not true. Okay, so I'm just gonna leave this. I'll end the video here, so thank you for watching, and I'll see you in the next video. Goodbye. Bye.